Hi everyone, I'm going to demonstrate how we might sketch this exponential function. Now this one, I must say, is a bit diabolical, so I hope this goes okay. The problem that I see is here. We have this coefficient 0.5 multiplying by the exponent x. Now I don't like them when they're like that, so let's just do a little bit of algebraic work on this first. So I have a base of 0.4. Now I will factor the 0.5 and I'll write this as x subtract 4. So if I multiply that through, that would be the same as we had 0.5x take 2, and I still have plus 1 as a vertical shift. Now I'm going to think of this as a different base. I'm going to write this as 0.4 to the power of 0.5, all to the power of x take 4. So having a multiplying coefficient here in front of the exponent x, it's really like having a different base. Rather than a base of 0.4, we have a base of 0.4 to the power 0.5. It's just a different number. Now I'm really hoping this was a tech active question, but I don't know for sure, so I'll work as if it's tech free. So a little bit of work to the side. What is this number? 0.4 to the power of 0.5 is the same as a square root. I'm going to think of 0.4 as 2 over 5, square root 2 over 5. Okay, let's write this as root 2 over root 5. Let's rationalise the denominator. I think this is, I'm making this, I think, a lot harder than anything I would expect of you. This is a pretty nasty question. So that is root 10 over 5. That's my number. Now I know that root 10 is just a bit more than 3. 3 3s are 9, but 4 4s are 16. So root 10 is approximately 3. I'm going to say that this is approximately 3 over 5, or 0.6. I know that is very, very rough, and if I was wanting a more accurate answer, I'd obviously use technology. I'm just going to go with 0.6 as my very rough answer for the new base. So here I go. That's approximately 0.6 to the power of x take 4 plus 1. There's the function that I'm going to sketch, and I do admit that this will be rounded off quite a bit. Now my base function here, my base function is the base 0.6 to the power of x, and then we've got a vertical scaling factor at the front, we've got a horizontal translation and a vertical translation. So my question really comes down to, what is this base function look like? 0.6 to the power of x. So let's start a rough sketch. Now I'm only thinking of the base function 0.6. If x equaled 0, 0.6 to the power of 0 would equal 1. I would have a value here of 0, 1. If x equaled 1, I would have 0.6 to the power of 1. So if x equals 1, I'd be a little bit lower down. So that's x is 1 and the function is 0.6. Now if x equaled negative 1, I would have 0.6 to the power minus 1. I would have 1 over 0.6, remembering that 0.6 is the same as 3 on 5, then I would effectively have 5 on 3, and 5 on 3 is the same, 5 on 3, that's 1 2/3, or about 1.67. So it's up here somewhere. Now that's all I really needed. I've got three points, negative 1, I'm just going to go 1.7, you know what, I'm being rough enough as it is. So that's an exponential function. It's a decay function, so it's dropping down, asymptotically approaching the x-axis here. Those are the 3 points that I'm going to transform. Now, as always, we work from what we've got there. The next little bit we'd have to worry about would be this subtract 4. The effect of subtracting 4 is to shift all of these points 4 units to the right. So I'd have to jump all the way over to here, at adding a 4 onto the x, that would be a 5 and an 0.6. Adding 4 onto that one will be coordinate 4, 1. Adding 4 onto that one will be coordinate 3, 1.7. So I've done that bit. Now the next part is, after we've dealt with all that, we would multiply by negative 3. So we're multiplying the function value, the y value, by negative 3. So if I multiply, say 1 times negative 3, I get negative 3. That's all the way down there, isn't it? So that's at 4, negative 3. Then I'll multiply 0.6, so I'm at 5. And minus 3 times that is minus 1.8. And then I'm at 3, and 1.7 times 3, that's 5.1, isn't it? So I'm all the way down here somewhere at negative 5.1. So I have multiplied by negative 3. The last thing is to add 1. So I'll go back to I'll use green. Why not? Got a different colour, might as well use it. So this will pop up by 1 step. This will be 5, and I think this is where it'll finish, and popping that up by 1 should be at negative 0.8, very roughly. Popping that one up should be at 4, negative 2, and then moving that up by 1 step should be 3, negative 4.1. So I think my exponential curve will go like this. Now it should have an asymptote. It should have an asymptote at y equals positive 1, the size of the vertical shift. So let's just make that look like that. That's a very messy diagram. I'm embarrassed to draw that diagram for you. But let's check on our graphing calculator. I've entered the original function the way it originally appeared with the 0.4 and the 0.5 and everything in place. Let's draw that. There's my picture. Now I'm going to hit the trace key, and I'm going to move to these points where x equals, oh sorry, I didn't mean to bump that, when x equals 3. So let's move to where x equals 3, and I've got negative 3.7. Well, I did round off a lot. Remember, I rounded the base off to 0.6. I think that's close enough for jazz. Let's check this next one here at 4, negative 2. I'm feeling a bit more confident about that one. That's good. And then the next one is supposed to be 5, negative 0.8. Oh, not too bad. Happy enough with that. And it certainly looks like the asymptote is at the line y equals 1. So that's how I would solve that one. Thanks for watching.